All right, so the new standard that we're going to start working on is simplifying rational expressions. So again, rational functions are any function that has x in the denominator. So we're going to be multiplying, dividing, adding, subtracting fractions, but with x. So it can get a little bit confusing. So we're going to split it into several days. We're going to start with just multiplying and dividing today. And so first we should review what you do when you multiply just regular, only numbers involved fractions. Okay, and it's really the simplest expression that you can have is multiplication, because all you got to do is multiply across the top and multiply across the bottom and then simplify your answer. So 3 times 2 is 6, 4 times 5 is 20, and we can simplify that to 3 over 10. Okay, now some of you might already be noticing that we could have maybe simplified a little bit before we even did the multiplication. So if we go back a little bit to the original problem, we may notice that, hey, I've got 2 on the top and 4 on the bottom. I can simplify that to be 1 on the top and 2 on the bottom. And so if I do that, I get the most simplified answer right off the bat. Okay. Same thing for this bottom one here. We can multiply straight across the top and get 18, straight across the bottom and get 28, and that simplifies to 9. Oops. 9. Yeah, 9 over 14. Or we can try to simplify before we multiply. 6 over 4 can simplify to 3 over 2, and we get 9 over 14. Either way, we get the same answer. The main idea here is that you're multiplying across the top. That's your new numerator. You multiply across the bottom. That's your new denominator. So we can also do this with some x's. So here, okay, multiply across the top. 3 times x squared is 3x squared. Multiply across the bottom, 4 times x. Remember that x squared just means x times x. And so we can cancel out one of those x's, and our most simplified answer is going to be 3x over 4. Okay. One thing that's going to help you as we start to throw x's and stuff in here is anytime you see multiple terms here, I would put parentheses right away. Okay. Otherwise, you might be prone to make some mistakes, because when I multiply here, I need to make sure I multiply the 2 times the x and the minus 1, not just times the x or just times the 1. And on the bottom, I need to multiply the 4 by the x and the minus 2. Now, right away, and you may have noticed this from the beginning, 2 over 4, that can be simplified to be 1 over 2. So on the top, I don't really have anything happening. 1 times x minus 1 is just x minus 1. And on the bottom, I can distribute that 2 or not. Either way, either of these answers would be fine. Okay. With this bottom one here, x minus 1 times x plus 3 over x minus 2 times x minus 4. If you are not told that you have to go to standard form, you could stop right there. That's factored form. If you are asked to go to standard form, then you'll FOIL the top and the bottom. So we'll do x squared plus 3x minus 1x minus 3 over x squared minus 4x minus 2x plus 8. And that can simplify to x squared plus 2x minus 3 over x squared minus 6x plus 8. And that's standard form. Again, if you're not told which form to do, keep it simple. Leave it in factored form. Okay? These ones not too bad. One thing to notice about these was that there was nothing that we could factor ahead of time. These can get a little bit more complicated, when you have obviously a more complicated equation like this, if you have x squareds in your equation, don't just start multiplying stuff together because you're going to end up with something that's very difficult to simplify. It will be much easier to simplify if you factor everything you can first. So let's see, x squared plus 1. That's sum of squares. That's not factorable. X squared minus 9. That's difference of squares. That is factorable. The square root of x squared is x, and the square root of 9 is plus or minus 3. So that's what that factors to. Okay, let's look at our denominators. Here we've got something. You can do the AC method, but if you can factor it in your head, even better. Okay, since our A is 1, our A times C is going to be 9. And we want to multiply to 9, but add to negative 6. So if we're multiplying to get a positive, but we're adding to a negative, they must both be negative. And 3 times 3 will give me 9. And add to 6. And then x minus 1 is not something that we can factor. There's no x squared. So I'm going to write this now in my factored form. I've got x squared plus 1, which I could not factor. I've got x minus 3 times x minus 3. And then I'm multiplying by x plus 3 times x minus 3 over x minus 1. Okay, multiply across the top and bottom. X squared plus 1 times x plus 3 times x minus 3. On the bottom, x minus 3 times x minus 3 times x minus 1. Okay, and now I'm looking to see if I have anything that I can simplify. Well, I see x minus 3 on the top and on the bottom, so those cancel. And that's it, because these ones are not the same. This one's plus and this one's minus. So my final answer, the most simplified answer in factored form, would be this. And the order that you write the things in parentheses does not matter. And since we were not told to go to standard form, I'm going to leave it in factored form. Okay. Let's do division now. Okay, division, very much the same, very similar as multiplication. There's just one more step. And so one kind of saying that's worked for a lot of people has been keep, change, flip. So you're going to keep the first fraction the same. You're going to change the division to a multiplication, and you're going to flip the second fraction. And now it's become a multiplication problem. Those two things are equal. So when you're dividing by a fraction, you can multiply by the reciprocal, the flipped version, and it's the same thing. And then we just get 15 over 8, which cannot be simplified. Okay. Again, keep, change, flip. Keep the first equation the same, change the division to a multiplication, flip the 6/7 to be 7/6. 21 over 24, which simplifies to 7 over 8. Okay, we could have simplified that right here and gotten 7 over 8 either way. That's your most simplified answer. And the basis is the same when we get to our more complicated equations. Okay, we're going to keep that whole first fraction the same. So x squared minus 9x minus 10 over x squared plus x minus 6. We're going to change the division to a multiplication, and we're going to flip the second equation. So now it's x squared minus 4 over x squared minus 1. And then we follow the same steps that we were doing before. We factor everything we can first before we just start multiplying willy-nilly. All 4 of these numerators and denominators can be factored. So let's do the easy ones first. Difference of squares. X squared minus 4 will factor to x plus 2 times x minus 2. x squared minus 1. Square root of 1 is just 1. So x plus 1 times x minus 1. Okay. AC method. Our a is 1, so that makes it a little bit easier. 1 times negative 10 is negative 10. I've got to multiply to negative 10, but add up to negative 9. So it's got to be negative 10 and positive 1. Negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. And then this is a 1x here. So similar idea. Got to multiply to negative 6, but add up to positive 1. So it's got to be plus 3 and minus 2. All right, now I'm ready to multiply. So I'm going to write my new fraction with everything factored. So I've got x minus 10 times x plus 1 over x plus 3 times x minus 2. Okay, and then I'm going to multiply by the stuff in the second fraction. So on top I had x plus 2 times x minus 2. On the bottom I had x plus 1 times x minus 1. Anything that's on the top and the bottom will cancel. So the x minus 2's and the x plus 1's. So I'm just left with x minus 10 times x plus 2 and x plus 3 times x minus 1. You can leave it in factored form. Okay. If you had just multiplied everything together across the top and the bottom, I don't think you would have been able to simplify this. So it's important that you always factor first and then see what you can do from there. Let's do one more. And I'm going through the factoring parts pretty quick. If it takes you longer to factor, that's okay. I'm not going to ask you to do a lot of these. Just doing the hardest ones together. So it's division. So we're going to keep the first fraction. We're going to change the division to a multiplication, and we're going to flip the second fraction. Okay, let's do the ones that don't have the 2's in front of the x squareds first. Those ones are easier. So I've got x and x. I need to multiply to negative 4 and add to negative 3. So negative 4 and 1. Okay. I need to multiply to negative 8 and add to negative 2. So negative 4 and 2. All right, now these ones I'm going to have to do more of the AC method. So let's see. A times C, 2 times negative 6 is negative 12. I need to multiply to negative 12 and add to 1. So I've got 2x squared. And instead of plus x, I'm going to, let me rewrite it. I'm going to do 2x squared plus 4x minus 3x minus 6. So I can factor by grouping. Greatest common factor, the first two terms is 2x. So I got to divide the last two terms by negative 3. I get 2x minus 3 times x plus 2. Just so I don't lose myself here, do some color coding. So I can see which ones I have factored and which ones I haven't. So I've got one more left. Okay, again, a times c, 2 times negative 3 is negative 6. So I'm going to split that middle term into negative 3x and positive 2x. Those multiply to negative 6 and add up to that negative x. GCF of the first two is x, leaving me with 2x minus 3. And this one's already 2x minus 3, so we'll just divide by 1. All right, let's put everything together. So on the top, I'll have now factored 2x minus 3 times x plus 2 over x minus 4 times x plus 2. And then from the second fraction on the top, x minus 4 times x plus 1. And on the bottom, x plus 1 times 2x minus 3. The 2x minus 3's cancel. The x plus 1's cancel. The x minus 4's cancel. And the x plus 2's cancel. Anything divided by itself is 1. So after all that, my final answer is just 1.